back to this first answer, this is really important. Okay, this is where I want people to start paying attention. We're like half an hour in already.
I know, right?
A 51% attacker, they cannot generate more coins. Okay, right now miners create 2,000 HNS per block. You can't change that. That's a validation rule. They can't create coins out of thin air, and they can't steal your money, and they cannot, in our case of Handshake, cannot steal your domain name. That is a completely different security model. That's about private keys. So a 51% attacker does not control your wallet. You have not been hacked. So if you, so one of the tweets this weekend was about destroying domains. That's not really possible. For example, my domain, proof of concept, the DNS records for proof of concept are in the blockchain, and they are so old. I mean, I sent the update months ago. Reversing that transaction, even just to remove those records from the blockchain, is impossible at this point. It would be so expensive. It's not even, you can't do it. You can't do it with a 51% attack for 1 hour. Okay, you would really need to destroy the whole chain in a way that at this point is probably impossible or so unlikely. It would cost so much it wouldn't be worth it. And even then, you could not change the DNS records. You can't change a transaction that I have signed with my private key. You can't say, oh, proof of concept doesn't go to this IP address anymore, it goes to this one. You can't do that because I've got the private key. What you could do theoretically in the Handshake system is rewind the chain so far that you actually change the outcome of the auction in which I won the name. That is where Handshake sort of diverges from Bitcoin. So if there's and this is, again, a real risk today. If there is an auction for a name that is high value, let's say it's .sex or something like that, or .com, God forbid, when this starts happening.
Yeah.
That is a name that is going to be a very intense auction if it actually hits if we get there. It might be worth it to somebody to actually try to invest whatever it's going to be, $1 million, $5 million, to mine all the blocks for the entire 5-day bidding phase. That's like, it's 500 or 600 blocks. It's going to cost a fortune, but they could censor the entire auction. That's a risk. That's a real risk. It's an expensive risk. And we can do the math and figure out what it would actually cost for somebody to censor an entire auction, and then decide if it's worth it for that, if that attacker wants to spend that much money to completely censor the COM auctions that they win COM. That's a real risk. Yeah, that's something we need to be aware of. And the only solution to that is more hash rate.
All right. So it's always a pleasure to have Matt back on the channel. Thanks for coming back, Matt. How's it going?
Great, man. Thanks. I want to say on record, great job on HandyCon. You and Jihan Fistful did a killer job. Community is on fire because of your efforts, and on behalf of everybody, thank you.
Awesome. Our pleasure. Yeah. I mean, like I said before recording, I mean, we don't have the big centralized marketing budget like VC funded naming spaces. I won't name, but yeah, I mean, the community is hard to, I think community is the most valuable part, and it's exciting part. It's also seemed to fire up in Twitter again, and it kind of inspired this session we're doing right now. Like, I don't know if we need to read the tweets, or I might quote the tweets in the show notes. But a common argument against HNS is, why does it have its own chain? Why is it proof of work? It's a small chain, 51% attack. It's, you're risking. They some of these critics say it's dangerous, to build on this so yeah, I looped you in on that tweet, and then it inspired today's recording. I think even some people on that thread are excited to hear. So, I wasn't even sure how to answer. That's kind of why I'm even learning today myself. That's why I like this. I get to ask you questions and learn myself. So, where should we start, or how do you do this?
Well, let me start off by saying that Handshake is a risky asset. Okay, some of the criticisms are valid, and even like at the HandyCon talk, there's a little bit of back and forth between myself and Andrew and JJ about how safe is it. Just because something is on a blockchain doesn't mean that it's totally secure. Attacks can still happen against a blockchain, and all cryptographic systems actually. When it comes to cryptography and blockchain especially, what we talk about is kind of the cost of an attack. nothing is secure. Nothing is secure. Locks have keys. Locks can be picked. Even the private keys that you generate that are these huge random numbers can theoretically be cracked just with an expense that is so enormous. We, for all intents and purposes, consider them secure. To break a private key would cost more money and more energy than is available in the universe, but it's possible. So, it's just highly improbable. So when we talk about these things, we talk about the cost of an attack, and some systems are more expensive to attack, cheaper to attack than others. And because Handshake is a new chain with relatively little value compared to Bitcoin and Ethereum, let's be honest, and the hash power is minimal compared to the two major chains, we have to be honest that Handshake is risky. But hopefully we can talk about the facts today and define what mining is and how it works and what specifically a 50% attack is. And what those risks actually are for asset holders, and how some of the tweets over the past couple of days were on point and how some of them were exaggerated.
Okay. Yeah, it sounds good. I mean, I think we always appreciate your, I guess because you're so technical, you kind of just tell it how it is, sometimes it's not what the marketers or the hype, which is I appreciate about this community and you. But sometimes we almost are too cautious or too, but I guess it's better to be safe than sorry, right? Or it's better to make sure people are aware of the risks.
Right. Yeah. I'm a Bitcoiner who is working on an altcoin. So I have, I'm not a full on shill. I don't think Handshake is going to solve everything. I don't think it's impenetrable. From a perspective of a Bitcoiner, and I'm wearing my full node maximalist shirt today.
Awesome.
It's for the occasion.
Okay.
All right. So should we start off by talking about, should we just jump in?
Yeah. I think we're ready. I mean, I'm ready to listen.
Okay, great. And, like usual, stop me with any questions along the way. So I'm going to start off talking about some resources, because I'm not a total expert on this. I want everybody to be able to look stuff up on it, obviously too. If you guys can see my screen, right? We're good.
Yep. I see it.
Okay. Link number one, Bitcoin.pdf, the Satoshi Nakamoto white paper, the beginning of it all. And even in this paper, if you scroll to the bottom, calculations, this is the last section in Satoshi Nakamoto's white paper. And what he actually wrote here is basically what I was talking about, the cost of an attack. There could be a dishonest miner, somebody who is censoring transactions or trying to reverse the blockchain, which I'll explain. And Satoshi acknowledges that is a possibility. It also puts some calculations here for how to figure out what that kind of attack will cost. And finally, prints out a couple of numbers where he talks about the probability that an attacker can reverse a transaction. Because from Bitcoin's perspective, that's what it's all about. The worst thing that could happen is that I pay you some amount of Bitcoin, you give me goods, and I walk out of the store. And then later the transaction goes away, is double spent, that the coins don't go to you at all, they go to me. And that theft or whatever, the undoing of that transaction gets confirmed, and I've got your goods and you've got nothing. So that's the real 51% attack. So let's talk about how that can happen. Miners play this game where they buy equipment and they spend money on electricity, and they put those two things together to basically come up with a random number, like rolling a die. And if that number is below a certain limit, then they get to broadcast a valid block to the network and create coins for themselves and confirm transactions. And that process is so hard to do that that's where we get our security from. Or I should say it's so expensive to do, because we're talking about cost of attack. So if everybody in the network is being honest, we have a lot of hash power adding blocks onto the chain. And the more blocks there are on a chain, the more confirmations a transaction has, the harder it is to undo. Because the way that full nodes work is we try to find the chain with the most proof of work, the hardest chain possible to have been created. So how the 51% attack works in Satoshi's case is that basically I am a miner, or I collaborate with a miner, and I send you a Bitcoin transaction, and you're a good boy, and you wait for that transaction to confirm, and you see it in a block with proof of work on top of it, and you're like, okay, this is probably safe, and you give me the goods. And then I go tell the miner, I'm like, hey, I need you to undo that block and put another block on top with this other version of the transaction, an alternate universe of the transaction, where the transaction doesn't go to Mike, it goes to me. And then build more blocks on top of that, so he never gets the money back. The transaction is just totally not recoverable. And the question is, how easy is it for a miner to do that, to undo a block? And the thing is that the way that the blockchain works is typically miners want money. This is the other thing we're going to have to talk about today, is the incentives. So miners are usually, normally, and honestly interested in creating a new block, the next block, because that's how they get money. But could they be incentivized to, instead of creating a new block, create an alternate block at the same height as the current chain? So let's say we got a blockchain. We got block 1. I should have got my kids' Legos here. Block 1, block 2, block 3, block 4, right? What if instead of block 5, let's say, instead of a miner building on block 5, they build an alternate block 4? Those two blocks will basically cost the same, right? They'll cost the same amount of money. You're going to spend the same amount of hash power, same amount of electricity, same equipment cost to do that. Now, what's more likely is that block 5 will be mined by someone on the network because of everybody is trying to do the same thing. But if somebody is trying hard enough, they could create an alternate block 4, or maybe even alternate block 3, or an alternate block 2, or God forbid, a chain of like 10 blocks going all the way back down here and trying to erase or reorganize the entire chain. So any questions so far? Does that kind of make sense? I don't have slides for that part, but
it generally makes sense. I mean, I never thought that, but it never goes backwards, right?
It can go backwards.
You could go next to each other, like you're saying, block 4 twice. I mean, that's an attack, right? But there's nobody could reverse a previous transaction. I've heard of people talk about this, but there's no way to go backwards, right?
Okay, let me be more clear. Let's say we're starting from total 0. Okay, there's no blocks in our chain. I mine block 1. And let's say I'm 100% mine. I've got all the hash rate, right? This is basically a centralized blockchain, let's just say. There's no blocks, then I create block 1. Then I create block 2. Then I create block 3. Now, you would expect me, maybe I'll create block 4, but I could also create an alternate block 3. I could also go all the way back and create an alternate block 1, 2, 3.
Okay, got it. Now it's clear.
Right.
I thought you could maybe at the same time, but you could also try to go backwards, of course.
Right. But it'll be harder because everybody out there is saying like, I'm like, you're a full node, and you're looking for the chain with the most blocks. That's incorrect, but let's just say you're looking for the longest chain. Okay. So right now there's a chain with 4 blocks on it. If I send you another chain with 1 block, you're like, well, I don't care. If I send you an alternate chain with 2 blocks, you're like, still don't care. 3 blocks, still don't care. 4 blocks, now you're interested. If I send you an alternate chain with 5 blocks, now you've switched. That is the chain with the most work. That is the new truth. That is what everybody in the consensus system will consider the most valid, and that is the state of the system. So if blocks 1, 2, 3, 4, the first 4 blocks I make, all the money's going to Mike, and you're like, I'm rich. And then all of a sudden this alternate chain comes along that is longer, where Mike doesn't have any money, you're SOL, your money's gone. The new state of the system is over here. But what we want to do is make that as expensive as possible. And that's where proof of work mining comes in. And also, like, you might not have time to really like dig into this, but where systems like proof of stake get a little more iffy there. Because the thing is, if I generated those first 4 blocks, I have wasted electricity I'm never going to get back. When I try to generate the alternate chain, I got to waste more electricity I'm never going to get back. Proof of stake works a little bit differently than that, because there's actually I'm actually like combining carbon with oxygen and creating fire and using that to power, there's chemistry that you can't undo. And that's why JJ would argue that proof of work is the only system worth doing. Okay. So, and maybe a better way to think about this is to stop using the word chain. The actual data structure is a lot more like a tree. It's more like a tree. It starts from a root, the genesis block, and it can branch, and it does branch off. It doesn't just go straight as a chain. there can actually be little forks. And usually these little forks are small and we ignore them. And the job of the full node is to find the longest chain, the longest branch, the longest path from Genesis to whatever, the most number of blocks that lead back. And there are forks. And some of these forks might not have any money. Some of them might have money. But the consensus system is whatever has the most blocks. So what an attacker wants to do to change history is to create a longer chain than the honest chain, than the one where I pay you and you give me the goods, and then okay,
get it. Generally get it, yeah.
Okay, so mining is a game of chance. It takes equipment and it takes electricity. You put the electricity in the equipment, and it generates these random numbers. And if the random number is below a certain limit, then you win. The more equipment you have, the more chances you get. It's like a lottery. The more opportunities you get to play the game, and the more hash power you have. Also, other factors obviously come into play. If you have cheaper electricity, you have a bigger advantage. If you have more efficient equipment, you might be able to use the same amount of electricity to produce faster hashes. That's why, if you still have an HS1 from Gold Shell that came out 2 years ago, you're probably not mining any blocks. But if you've got an HS5, you might have a little bit more luck. So when we talk about a 51% attack, it's pretty simple. We're talking about a single entity, an attacker, that has more hash power than the entire rest of the system combined. That, by definition, 51% attack. And what we want to know is, what can that person do? If we're just talking about a regular game of chance, like dice, 51% means that the 51% attacker will generate 51% of the blocks. That's basically how it works. They roll the dice 51% of the times. The rest of the network rolls at 49% of the times. They are likely to generate 51% of the blocks. You can imagine every other block. So they do. It's not totally centralized still. There's still some diversity there. And the whole reason that blockchain is decentralized is the idea that there is more than one miner. If I'm a mining pool and I'm like, I hate Mike, I'm never going to confirm any of his transactions in any of my blocks. Ideally, there is at least one other miner out there that will be happy to accept your transaction fees to put your transactions in their blocks. The more mining pools there are, the more decentralized it is. If there's only one mining pool and the US government comes to me and says, Mike Malini's out, or we're sending you to jail, I'm like, sorry, Mike. But ideally, there are mining pools in different countries, different jurisdictions, and enough mining pools that they can't collude into a cartel. All right, so what can a 51% attacker do? A 51% attacker can do, well, let's see what kind of my links. Okay, here we go. All right, so bitcoin.stackexchange.com is a great way to learn about Bitcoin and therefore Handshake. And there's a lot of links there about 51% attacks. So you can just come to bitcoin.stackexchange.com and look it up. Let's just read it right off the page here. What can a 51% attacker do? They can reverse transactions while they're in control. And while they're in control is an important part of this too, because a 51% attack is not a permanent situation. Like I said, it takes equipment, it takes electricity, it takes consumes resources to be a 51% attacker, and you might run out. If you're intentionally trying to attack somebody, that attack might be worth it. For example, if I'm sending you $1 billion Bitcoin transaction and I let 6 confirmations go by and it only costs me $1 million to attack and reverse that transaction, profit for me, I win. I get my $1 billion back. It only cost me $1 million. So again, the concept of cost of attack, but also the attack is not permanent. They last for until you give up or run out of money. Okay, so a 51% attacker can reverse transactions while they're in control. They can prevent transactions from being confirmed, and they can prevent other miners from getting blocks. So I've basically explained all this stuff already. I can reverse a transaction by confirming an alternate version of the transaction. I can prevent transactions from being confirmed. That's just censorship. That's why we have decentralized mining. Censorship is the opposite of decentralization. Decentralization prevents censorship. That's why, because if the 51% attacker decides to censor you, you are less likely to get a transaction confirmed. And they could prevent other generators from getting any generations. That means that, like, if I'm committed enough, I can try to create every block. So what I said, that a 51% attacker will eventually create 51% of the blocks. A dedicated 51% of the attacker can also approach 100%. This is Peter Willa, arguably one of the smartest Bitcoin scientists alive. Because, like, if I'm 50%, you're 50%, and I lose, and Mike makes a block, I have the choice to either make the next block or replace yours. And if I make that choice, I can eventually, over time, if I have infinite money and persist with 51% hash rate, I can eventually overtake and centralize the entire system. So when a 51% attack starts, that miner basically just creates every other block. But they can, if they're dedicated enough, try to make every block by preventing other miners from making blocks and replacing their blocks. Back to this first answer, this is really important. Okay, this is where I want people to start paying attention. We're like half an hour in already.
I know, right?
A 51% attacker cannot. Let's see, what's the most important part? These last three are kind of the important ones. They cannot generate more coins. Okay, right now miners create 2,000 HNS per block. You can't change that. That's a validation rule. They can't create coins out of thin air, and they can't steal your money. And they cannot, in our case of Handshake, cannot steal your domain name. That is a completely different security model. That's about private keys. So a 51% attacker does not control your wallet. You have not been hacked. So so one of the tweets this weekend was about destroying domains. That's not really possible. For example, my domain, proof of concept, the DNS records for proof of concept are in the blockchain, and they are so old. I mean, I sent the update months ago. Reversing that transaction, even just to remove those records from the blockchain, is impossible at this point. It would be so expensive. It's not even, you can't do it. You can't do it with a 51% attack for 1 hour. Okay. You would really need to destroy the whole chain in a way that at this point is probably impossible or so unlikely. It would cost so much, it wouldn't be worth it. And even then, you could not change the DNS records. You can't change a transaction that I have signed with my private key. You can't say, oh, proof of concept doesn't go to this IP address anymore, it goes to this one. You can't do that because I've got the private key. What you could do theoretically in the Handshake system is rewind the chain so far that you actually change the outcome of the auction in which I won the name. That is where Handshake sort of diverges from Bitcoin. So if there's and this is, again, a real risk today. If there is an auction for a name that is high value, let's say it's .sex or something like that, or .com, God forbid, when this starts happening.
Yeah.
That is a name that is going to be a very intense auction if it actually hits if we get there. It might be worth it to somebody to actually try to invest whatever it's going to be, $1 million, $5 million, to mine all the blocks for the entire 5-day bidding phase. That's like, it's 500 or 600 blocks. It's going to cost a fortune, but they could censor the entire auction. That's a risk. That's a real risk. It's an expensive risk. And we can do the math and figure out what it would actually cost for somebody to censor an entire auction, and then decide if it's worth it for that, if that attacker wants to spend that much money to completely censor the COM auctions that they win COM. That's a real risk. Yeah, that's something we need to be aware of. And the only solution to that is more hash rate. So let's any questions so far, or I kind of want to.
Yeah, I'm getting it. I mean, I think those are important points. Like, they can't change the domain records, but I guess the way they could hack it is going back to when that auction happened. But the further back, the harder it would get to do that 51%.
Yes,
attack.
The more expensive, right? A 51% attacker right now could screw with stuff right now on the tip, maybe the last couple of blocks. So one of the tweet that you invited me on the thread was about a 51% attack lasting 2 hours, costing $2,000. What could that attacker do? Not much. Censor transactions for a little while. maybe reverse a couple blocks, reverse a transaction. So, and this is also why Namebase waits for 20 confirmations. So actually, that $2,000 2-hour-long 51% attack would not even be able to steal money from Namebase because they wait 20 confirmations. And if I were Namebase and you sent me a deposit for, let's say, 1 million HNS, I would wait 50 confirmations, for this reason, because at that value, it is worth it for you to try to attack the chain. Okay. Yeah.
Got it.
Okay. Quick quote from Greg Maxwell. I think people obsess far too much about 51%. It has some kind of attractive mystery to it that distracts people. If you're worried that someone might reorder history using a high hash power collusion, just wait longer before you consider your transactions final. I think that covers what I've been saying already. And this, by the way, is also why HNSD and HSD will do this eventually also. Wait 12 confirmations after every Urkel tree before resolving records. So if you update your Handshake domain DNS records at this moment, nodes like Fingertip and Beacon will still wait 2 hours before trusting those records. So there we go. Okay. Crypto51.app. By the way, Crypto51 was the first reserve name to be claimed on Handshake by the developer Tom. And I don't think he ever registered it, but he does get credit for having the first claim. So this site attempts to calculate what a 51% attack would cost for 1 hour. Remember, 51% attack is not permanent. It costs over time. The way all mining costs over time. You put energy in, you have to pay for that. After an hour, it's spent. All right, Bitcoin apparently will cost $2 million to attack for an hour. That's good news. If we scroll down to Handshake, here we are at about $1,000 an hour. So this means that, you can do this calculation too. I've done it on a Handshake issue recently. Basically, what you do is you find here's the Gold Shell HS5. You find the most efficient mining equipment out there, and you figure out its hash rate and the hash rate of the network, and you just say how much electricity does this thing consume, and you do the math. So right now, basically, roughly, Handshake miners generate 2,000 HNS per block. That's roughly $400, right? If we're saying 20 cents per HNS. I calculated that it costs about $200 worth of electricity to generate each HNS block. So right now, that's profitable, assuming you have to spend $7,000 on this piece of equipment. Once you've covered that cost, every Handshake block you mine costs you $200 worth of electricity. You get basically $400 worth of value from generating those coins. That's a pretty good deal. But those blocks only cost $200 to generate. If you want to undo 5 blocks, it'll cost you $1,000. That's cheap. That sucks. That's what we get for being a new blockchain, for being a minority chain with a low hash rate. Look how far down we are on this list. I mean, we're not as bad as, Litecoin Cash, $4. Okay. If you're Coinbase, are you going to list a coin called Litecoin Cash? That can be 51% attacked for an hour for $4? I wouldn't. And so forth, Bitcoin Gold actually had a 51% attack a while ago. We can talk about that. And their Crypto 51 prediction is about $1,700. So obviously Bitcoin and Ethereum are the most expensive to attack, the hardest to attack. So when we're talking about cost of attack, this website should make sense. Now, how practical is it? Over the weekend, there was a tweet. Someone was like, for 2 ETH, I can attack your network for 51% attack it for 2 hours. The correct response to that person is to say, go ahead and do it. If you 51% attack Handshake, I'll give you that 1 ETH. I'll pay for it. In fact, I'll give you 2 ETH. Go ahead and do it. That person also claimed that it would destroy the network and destroy the domains. As I've explained, that's not real. Go ahead and do it. If you can 51% attack Handshake for $2,000 and destroy my domain proof of concept, I will pay you back that $2,000 plus 100%. Okay, that's not real. I'm not actually doing that. I'm saying that is the correct response to that kind of trolling. And that's where we get into the question on how practical is it? Okay. And the decision that JJ and the founders made to create a brand new proof of work algorithm that was ASIC friendly. Now we have ASICs. No other coin in the world has the same proof of work algorithm we do. I'm going to skip ahead a little bit and show this chart. This is a mining stats chart listing all the coins that do SHA-256. All right. If you're mining Bitcoin with an ASIC, you can mine any of these other coins. They're all the same hash algorithm. Remember, Handshake is the only coin that uses its hash algorithm, and we can try to look that up too. But my point is that if you decide you're tired of Bitcoin, you've got this equipment and you're tired of mining Bitcoin, just scroll down here and 51% attack TerraCoin. You got the equipment sitting around. Maybe you send TerraCoin to Coinbase and then you want to 51% attack it and steal the money back. Okay. It's more practical when you are sharing a hash algorithm with especially Bitcoin, that has had ASICs for whatever, 15 years. So let's say you wanted to 51% attack Handshake. You were going to need some of these guys. You're going to need ASICs because right now, all the ASICs Gold Shell has made, and by the way, they are sold out. Let's just assume that they are in friendly hands, that the people who are mining Handshake right now with HS5s and whatever else want the chain to succeed. I mean, I spent $7,000 on an HS5. I don't want Handshake to get attacked. I don't want domains to be destroyed. I'm going to secure the chain. I'm going to spend electricity to earn HNS. And you know what? I'm even going to send some of this to the developers, and they're going to sponsor conventions and all that kind of stuff. And Gold Shell has sponsored the developer fund. If you're going to do research and development and create an ASIC, you need that project to succeed. You're investing in Handshake. You're not just going to go attack it. So who would do that? If you're going to attack Handshake, if you want to destroy it, maybe the US government is like, okay, and this is what came up at HandyCon. Let's say ICANN took the RU, Russia's country code top level domain, out of the root zone because of the story in Ukraine. And Russia was like, well, that's great. We can claim RU on Handshake. And we do that. Now we're going to use Handshake. And the US government is like, okay, now we need to destroy Handshake. That is reasonable to assume that the US government would want to destroy Handshake. Could they do it? Could they even 51% attack it? Well, if they wanted to do it the most efficient way, they need to get their hands on some of these guys, these machines, which are sold out. Maybe they don't exist anymore. They're all in friendly hands. Let's say there's 10,000 of these units and they're all over the world. I think last year at HandyCon, the CEO of Gold Shell said that they serve over 60 countries. Yeah. So if you're the US government, you want to destroy Handshake, you got to go around to those, at least 30 of those countries, right? 50%, steal all those miners and bring it back to the Pentagon and set them up. All right. That's going to be hard to do. And this is where ASIC friendliness is super important, because websites like NiceHash. NiceHash is a website where you can rent hash power from someone out there who already owns equipment. And it's especially useful for coins that can be mined with CPU or GPU. I'm not going to bother to try to figure that out. But equipment like GPUs, like graphics cards, can be reprogrammed basically to mine any number of coins. And the fact that the Handshake founders chose an ASIC-friendly algorithm to make ASICs means that GPUs can basically not mine Handshake anymore. So if you want to try to attack Handshake, you're going to need somebody with hash rate, and you can't just hire somebody on NiceHash with GPUs. So I actually looked up, if you want to rent hash rate for Handshake on NiceHash, there's only one, there's two options for you. And actually one of them doesn't look like it's working. And total available speed is 0.5 terahash. So whoever this person is in EU West probably has two of these machines. And basically they put it on NiceHash and they're like, if you pay me 0.06 BTC per day, I will hash to whatever address you want. You cannot 51% attack Handshake with this. The hash rate is way too low. So how practical. That guy who tweeted, I can 51% attack your chain for 1 ETH. Go ahead. Get started. Get start today. I'll give you the ETH to do it if you're successful. Practically, that's hard. Theoretically, it's very possible. But the theory involves finding this equipment or making it yourself. And like I said, for SHA-256, it's very easy to find equipment. For our hash rate for our hashing algorithm, it's not. Okay, so that's some things to feel better about. A 51% attack is theoretically possible, practically very difficult. Theoretically, even very difficult. It takes a lot of energy and expense to do so. And even then, you don't get that much out of it. And if you're going to go around the world and collect these machines from all the different countries and just go into people's houses and steal them, or insist that Gold Shell create you 10,000 new machines, honestly, the best thing for you to do is to mine Handshake. keep the chain going, secure it, send some of that HNS to developers to add value to the chain, wait a couple of years for the price to go up and sell it. Why would you attack the chain? The only reason would be some kind of like government censorship, Russia, Ukraine, okay, that kind of thing. War, where the whole point is to waste money to destroy something. Let's take a break. How are you feeling?
No, this is good, man. It makes you feel a lot better. I think others watched this still agree. I mean, but we should also, I don't know if we want to get there, but I think another way is, I do have an HS1. I did a video on the channel skyclo.com/mining. It's actually stopped working for me. I think, I bought it used anyway, but I mean, we should all be mining or not. I mean, should we, I mean, as people trying to support this chain, should we try to mine, get this equipment? Is that helpful?
I have seen a lot of that kind of sentiment come from the community since this has been a hot topic. And I'm not really sure what my opinion is on that. I don't think I would say everybody needs to run a full node. That's my deal. I got the shirt. But I wouldn't say that everybody needs to mine. It's just not practical. It's expensive. I would say if you're El Salvador and you got a volcano that's just shooting carbon dioxide into the atmosphere and you can capture some of that and generate cryptocurrency with it, sure. If you're a power plant that is in a remote area of China and you're basically wasting power or generating unused power, sure, mine some cryptocurrency. If you're an oil field in Texas and you're flaring your methane gas, this is another thing I heard about recently. Flaring is right. You burn this gas, right? Yeah. Right. Capture that, turn it into Bitcoin. Okay. Solar powered Bitcoin mining. Okay. Do that. We're not even talking about environmental impacts in this talk today, but everything I just said is basically renewable.
Cool.
So should everybody get a Handshake miner? I would say no. I think it should be what we need is to stop this. Okay. And this is a screenshot from a slide. I gave a talk like a year ago, and this is how it actually looks today. Basically has not changed. F2 Pool has 52% of the network. F2 Pool can censor transactions if they want. They can reverse auctions if they want. It's not a good look. F2 Pool is incentivized not to do those things because of everything I've already said. But let's say the US government goes to F2 Pool or something and insists that they censor the Russia transaction. They might be able to do that for a certain amount of time. It might cost them a lot of money. They'd be giving up honest handshake blocks to censor, But so, there's this balance of like cost of attack, practicality of attack, and we also need to be honest on the possibilities of an attack. The other thing I mentioned in this slide, I forget how long ago this was, but if you notice on the top right here, the 7-day history, there's a dip where all the major handshake pools lost hash rate at exactly the same time. Yeah. That implies that the hash rate is all in the same room under the same circuit breaker somewhere. I don't think that is the situation anymore, because I happen to know from Gold Shell that they had to move machines around because there's been a thing about proof of work mining in China lately. So I don't think all the machines are co-located anymore, but that is, handshake mining is not diverse. It's not diverse enough. We need more diversity. So I guess to answer your question, what I'd say is, well, if you are mining handshake, switch pools. If you're mining the F2 pool, look at this chart, mine to via BTC instead, or start your own pool. If you really believe in handshake long-term, start a mining pool, talk to Gold Shell or compete with Gold Shell. This is the other thing that we really need is somebody else to make ASICs besides Gold Shell and compete. And then we can have a marketplace there. Bitcoin and Ethereum have already got this. This is what we need. And the way that you, Mike, and the listeners of your channel could do this is simply by adding value to the Handshake ecosystem. Make cool websites, tell everybody about it, help start businesses, help run exchanges, add value to the system so that, somebody at Gold Shell looked at Handshake and was like, this is a great idea. We're going to invest money in it. We're going to profit. We need more people to look at Handshake and do that. Yeah. And I think we can do that by adding content to the chain. And
yeah, it's been getting exciting. I mean, like you said, there's some really talented developers building, and yeah, there's more things being added. I mean, the whole chat system now, HNS chat, he's been grinding hard, Jordan. And there's lots of great things happening there. HNS funded a competition for building and some other. I even saw like register like some Twitter registry not registry, but he's selling SLDs and he's trying to do a competition of people build on his TLDs. He'll give like prizes and stuff. So it's been a lot of cool things happening.
Yeah.
But yeah, I know you're so busy and I really appreciate this. This is I think we covered major points and definitely answered the question. So maybe I'll try to summarize and you correct me if
Sure.
I think the main point is the mining machines are not the same as Bitcoin. So if somebody want to do an attack, it would be easier for them to do it on a Bitcoin compatible machine. So
on a Bitcoin compatible chain, like
like
chain
having mining equipment or like SHA-256 machine. That's what I meant. Like
right.
So they would need to get special equipment to do it on Handshake, and it's sold out and it's only on Gold Shell for now. So they have to find these machines and get enough of them to take over 51%. And then even if they were able to do that, they'd only do a certain amount of time. And the longer the time, the more the cost, and it would destroy the network. So they would really only be doing this if they wanted to destroy value and money, because why would that, like you said, if they're like a government or somebody trying to censor information, but there's no financial reason. Well, I guess maybe if they wanted to reverse an auction to take a domain in the auction, but they can't change the records of a domain that somebody else owns. They would have to go back to that auction and then win that auction to take that domain.
Yep. You got it. You got it all. Yep.
Okay.
Yep. The other couple of links I was going to show off here were just 51% attacks that have happened on chains that you might know about. Bitcoin, this is from 2 years ago. Bitcoin Gold is 51% attacked. They say network loses $70,000. That doesn't make sense. A network can't lose money, but probably somebody sent Bitcoin Gold to an exchange and then managed to reorg the chain, replacing 29 blocks. That's a big change. I mean, that's a couple hours worth. And again, Bitcoin Gold is a SHA-256 chain. So somebody who mines regular Bitcoin could just get bored and attack a chain like this. Ethereum Classic, same thing. Third 51% attack in a month. Oh my God, this is August 2020. Same kind of thing. 77,000 blocks. I don't know how long. I think blocks on Ethereum are like 10 or 20 seconds apart. So that's a couple hours. Still seems like a lot, 7,000 blocks. And probably the same kind of thing, like somebody who is mining on Ethereum already and has hash power to mine honestly on Ethereum can just get bored or have a financial incentive to attack. So 51% attacks do happen. They are real. Yeah, I think we've covered the risks. And also when you say 51% attacker can destroy the network, don't forget what a 51% attacker can actually do and more importantly cannot do. They don't have your private keys. That's a different security model. No 51% attack in the universe is ever going to steal your private keys.
Got it. Okay. Yeah, I think we covered it really thoroughly. So I'll try to put some notes also in the link. I don't know if you want to send me those links.
I'll do that.
Yeah, and then I can stick them in the notes. All right. Really, what's the best way, people find you or any other?
You can't find me. I'm a ghost. I'm invisible.
Yeah, you're everywhere. People can just find you.
I'm an enigma. Matt Zipkin's not even my real name. Forget about it. This is the last you're going to hear of me.
Yeah, I mean Telegram groups, developer groups. Matthew Zipkin on Twitter, right? And
yeah,
awesome. Thanks so much, man.
All right, thanks, Mike.